All right, thank you, everybody. My name is Chris Addy. I'm one of the trustees for the Massachusetts Nature Conservancy in my third year, and I've been a longtime supporter of the organization. I'm also a former marine biology teacher, father of two, and a lover of the oceans. I'm even wearing a fish scale shirt today to prove it. So I'm excited to introduce this session and listen to Chris today as he shares about the Nature Conservancy's marine programs. Before that intro, wanted to share a few reasons why I think this work is so important and so exciting to complement what I'm guessing Chris will talk about. The first is that, as you all are likely aware, ocean health is absolutely critical to our future. Every breath we take, half the oxygen comes from the ocean. It provides food for us and many others. And oceans are incredibly resilient. Just this morning, I went for a bike ride, and unfortunately, I don't live super close to the ocean, but I do live close to a river, and that river has a herring run. Those herrings start in the ocean, and I saw two bald eagles. Now, mind you, I live less than 10 miles from downtown Boston. So because the herring have recovered to 5x the number of fish that go up this particular river in just the last decade, we had bald eagles, cormorants, seagulls. I came home and actually took my two daughters very early this morning, and they got to see the bald eagles as well. So they are super resilient. The other piece is that, as you will hear from Chris, the Nature Conservancy brings the best of science, cutting edge technology, and pragmatism to develop solutions that work for nature and for people. People like the fishermen that I was fortunate enough to speak to with Chris last fall down on the Cape as they talked about the programs that the Nature Conservancy has helped them develop. And most excitingly for me as a trustee, because the Nature Conservancy is both a local organization and a global organization, the innovations that Chris and his team develop don't only benefit our local ecosystems and economy, but they're also able to rapidly scale up to other geographies throughout the Nature Conservancy network. So with that, I'll turn it over to James to tell you a little bit more about Chris's specific experience and some of the logistics for today, and I'm looking forward to hearing, and thank you all for your attendance.
Thank you so much, Chris. Thank you for the wonderful introduction. And also thank you for your commitment and everything you do as a trustee of the Nature Conservancy in Massachusetts. I don't know whether I'm more jealous of your bald eagle sighting this morning or the fish scale shirt. I feel like I'm gonna have to up my game, my fashion game going forward. So I'm James Miller, the host today. Before we get started with the presentation proper, a little bit about our presenter, Chris McGuire. Chris is the Marine Program Director for the Nature Conservancy in Massachusetts. In that role, he's focused on implementing collaborative solutions to pressing fisheries and ocean conservation challenges. This includes an electronic monitoring project in the New England groundfish fishery and research projects focused on iconic species like Atlantic cod. Chris serves on state, regional, and federal advisory committees and working groups, and he regularly presents his work at national and international workshops and conferences. Before joining TNC, Chris sailed as an officer and then captain aboard tall ships and ocean research vessels for 17 years. He has a BA from Connecticut College, holds a 1,600-ton US Coast Guard Ocean Master's license, and he earned a Master's in Marine Affairs from the University of Rhode Island. I love talking to Chris and hearing from Chris, and I'm optimistic that you will too. A couple of notes about the webinar itself. Webinar attendees are muted. Chris is going to present for about 20 minutes, and after that, we will take your questions. Please share your questions via the Q&A function on your screen. If you have any technical problems with the presentation, you could let us know via the chat function. We will do everything we can to help. To get the best possible view of the presentation, we recommend that you go to the top center of your screen. There's a pull-down menu there. You open it up and choose Fit to Window. So with that, I'm going to hand it off to Chris. Welcome, Chris. Sound great.
All right, great. Well, thank you, Chris and James, for that great introduction. Today, I'm going to talk briefly about why you should care about ocean conservation and give some examples of how the Nature Conservancy is working on solutions to some ocean conservation challenges in Massachusetts. First, a fish science story, then a fish data story, and I'll wrap up by talking a little bit about climate change. One big challenge for ocean conservation in general is that our senses give us false information. When we stand on the beach and look out on the ocean, it looks fine, even beautiful. On land, when a forest has been clear cut or a mountaintop removed, it looks awful, and we know that people did something. But we just don't see that when we look out at the ocean. We need to dive a little bit deeper. Next slide. For a long time, people used to say the ocean was too big for us to impact, and it is really big. You already know the ocean covers 70% of the Earth's surface, but it also contains 97% of the water on Earth and 99% of all the living space on the planet. As Chris said, if you like breathing, you can thank the ocean, whose microscopic plants produce 50% of the oxygen we breathe. And do you think climate change is bad on land? Well, you could thank the ocean that's absorbed 90% of the heat and 30% of the CO2 emissions since 1970. The ocean drives the weather on our planet by distributing heat from the equator towards the poles. It feeds us. Over 3 billion people get more than 20% of their protein from seafood. And 10% of the global population rely on the oceans for their jobs. So it's big. But is it too big to fail? We used to think the ocean was unlimited. The trouble is that there's now overpowering scientific evidence that people are changing it. Our news feeds are full of depressing stories of overfishing, ocean warming, habitat destruction, pollution. Globally, a third of fish stocks are overfished, which overfished means we're catching more fish than can reproduce and catch the same amount next year. And that's a threat to food security. And the impacts of climate change just add to that. Fishing is a pretty big deal. So maybe the ocean isn't too big to fail. So how can we chart a new course? We can't actually manage the ocean or the whales or the fish. We manage the people. Next slide. At the Nature Conservancy, we've been working for decades on land with people who depend on nature, like timber harvesters, farmers, hunters. They're often really great conservation partners because no one benefits more from well-managed resources than they do. That's true here in Massachusetts for fishermen and oyster farmers, like our partners that you see in these photos. We work collaboratively with these harvesters who are out on the water every day, and they know what the problems are. And together we come out with great solutions that benefit nature here in Massachusetts. And then, like Chris said, since the Nature Conservancy is a global organization, we can take the things we learn here and expand them across the globe. Next slide. So I'll start off with one example of our work. This is the tail, pun intended, of Atlantic cod. There's really no more iconic fish species here in Massachusetts. There's a sacred cod hanging in the State House on Beacon Hill, and cod has been the mainstay of fisheries in New England for 400 years. But due to both fishing and now the impacts of climate change, cod are at a fraction of their former abundance. And there are no cod on Cape Cod anymore. As fishermen and managers try to rebuild cod, there's really two ways. We could either catch less or make more. This is a make more story. Turns out cod are really good at making more cod. They gather in huge groups to mate for a couple months of the year, around the winter holidays here in New England. One large female cod can release 9 million eggs in a mating season. But researchers in Massachusetts have shown that fishing at the same time can impact that and even break up those aggregations. A few years ago, I was sitting in the kitchen of a commercial fisherman in Scituate with a group of his fellow fishermen. And they were worried about declining cod numbers, and they were even more worried about what the management response to that decline would be, maybe imposing really big fishing closures because we just don't have good data about where the important places are. They wanted to help locate spawning cod in order to close an area big enough to protect the spawning behavior and small enough to let them still fish for other species like flounders at the same time. I'll just say it's pretty much unheard of for fishermen to come to an environmental group and advocate to close areas of a fishery. But that's pretty much where we are. Next slide. So we assembled a research team made up of state and federal scientists and researchers from the University of Massachusetts, Dartmouth, and got to work. Here's a picture of us on a sunny December day catching some spawning cod. This is sort of what fisheries research has looked like for centuries. We catch fish, we land them on deck, and we wonder what they were doing when they were swimming around. Here's where we're going to introduce some new technology. Next slide. So the black thing in the hand here is an acoustic transmitter. In each of the cod we caught, we surgically implanted one of these transmitters. They work sort of like the Easy Pass toll thing on your car's windshield. Every time a tagged fish gets in range of a receiver, which is sort of the toll booth in my analogy, the signal's recorded, and it does this for up to 6 years. What this lets us do is peek behind the curtain and see what happens when we toss those fish back in the water. Next slide. Like this. We tagged 317 fish over the course of a couple years. Next slide, please. Thank you. It's the one with the flying fish. We tagged 317 fish over the course of a couple years and deployed 50 of those toll booths to track where they were on the spawning grounds. This tells us a huge amount about the fish we tagged in the places where the receivers were. But wait, there's more. Next slide. We also employed another pretty cool tool to understand the private lives of cod. This is an underwater robot called a glider. It's equipped with both a tag receiver and an underwater microphone. It turns out that male cod make a noise with their swim bladder. It sounds sort of like, and they use it to attract females when they're mating. They only make that noise during mating times. It's pretty quiet, but so's the glider. And so we're able to deploy these gliders across our study area for months at a time, listening for the spawning cod. This gives us a way to collect information about all the cod in the area, not only the ones that we tagged. Next slide. So this is what it looks like when we put it all together and what the management result is. So just to orient you to this figure, this is a heat map of the likelihood of seeing a spawning cod in a different area. Red, lots of cod; yellow, a few less; and green, sort of the extent of where we saw them. We also can see in this, there's a blue line that represents the state waters. Now, fisheries are complicated in the way that they're managed, and they're managed differently in state waters, which is out to 3 miles, and federal waters, which is outside of that. So this is a federal waters fishery. And what you see in the yellow line is a closure that was enacted based on the information from this project, which really surgically closes the area that's most important for cod spawning and gives cod, room to do their thing, and gives fishermen room to fish for more abundant species at the same time. This closure is about 1/10 the size of a previous cod closure that went into effect years before and should be just as effective. This method of tracking and listening to cod was really highly successful, and our research team is actually now using the same tools to look at spawning cod off of the coast of Rhode Island. Okay, next slide. So that's a story about how we better manage the information about one fish. Today, we're working on collecting better data about all the fish we catch. So information about what fish are caught and discarded at sea are reported by fishermen on handwritten, coffee-stained logbooks. And on a small percentage of trips, the government sends observers out to independently verify that information. Technology has transformed the way we collect data and information across most of our lives, but that tech revolution has been slow to reach fisheries until now. So those observers I mentioned, well, the cost of paying for them is being transferred over to the fishing industry. So fishermen approach the Nature Conservancy to ask us to help them to try out a cheaper and maybe better solution. It's called electronic monitoring. And basically, we use video cameras, like you can see in the yellow circles on the screen, to count and measure specifically the small percentage of fish that are required to be discarded during fishing operations. Next slide. So as the crews sort the fish, the camera focuses on the ones that are discarded. The good thing about putting cameras on fishing boats is you can record a lot of video. The bad thing is that you record a lot of video. About 50% of the cost of our program is video review, paying people to extract the fisheries data that we want from the video. So we're tackling that in two ways. First, the captains are now logging their catch on a tablet instead of on paper. And even though we're recording video on every trip, we're randomly selecting the trips to review and use video to validate the captain's record. For vessels who regularly match up the video and what they report is the same, we're reducing the percentage of video we review, and that saves a lot of money. The other way we're tackling the review problem is by using machine learning and computer vision tools to do the review. Next slide. So we hosted a data science competition, and one of the winners made this video of his algorithm at work. So here you can see the algorithm finds the fish with the red box, it measures it, draws the line, and then is IDing the species at the same time. It's pretty amazing. The winners were accurate, more than 95% on some parts and in the mid to high 80s on other parts. We're still working to refine this technology and make it work on every vessel, but right now we have about 10% of the fleet using these cameras voluntarily, and regulators in New England are considering rules that would encourage a lot more fishermen to use these kind of tools. Since we started this work here in New England, the Nature Conservancy is now running camera projects on the west coast of the US and in the tuna longline fishery on a project that spans 7 island nations in the Central Pacific. This tool has great conservation promise, and we're working with governments to accelerate its deployment. Next slide. So for decades, the biggest impact on our oceans has been unsustainable fishing. But as fisheries management improves, that impact is being reduced, which is really great. Unfortunately, at the same time, the impacts of climate change are becoming more acute, and especially so right here. The ocean off of New England is warming faster than 99% of the world's oceans. Fishermen out on the water see these impacts every day. Here's one fisherman's story about climate change. Next slide. I don't hear it. Does anybody else hear it? Okay, let's go to the next slide. So tackling what that story was going to and offshore is with offshore wind. We're reducing greenhouse. It's really important for us to reduce greenhouse gases. It's critical to moderating the effects of climate change. And in Massachusetts, we support the governor's commitment to make the Commonwealth net zero by 2050, which is awesome. Transitioning our electricity grid to renewables is a really important part of that plan, and offshore wind plays a really key role. And at the same time, widespread developments of energy infrastructure in the oceans is a really big change, and we want to do everything we can to reduce the impacts of that right from the start. I like to say this isn't an either or, but a both and. We can have both offshore wind and healthy oceans. Can you guys hear me now? Okay.
Yes, Chris. Yes.
You can hear me now?
Yeah.
Okay, sorry, I'm just watching the chat, which says you can't. Okay, like I was saying, we're working to make sure we can have offshore wind and healthy oceans. So we're working with scientists, ocean users, governments, and developers in the ocean and on land to maximize the benefit and minimize the impacts of shifting to a clean energy future. Next slide. Okay, so that's a whirlwind tour of a few conservation projects. And thanks to the ongoing support of our donors, the Nature Conservancy is working here in Massachusetts and around the globe to conserve the lands and waters on which all life depends, because we believe that nature's future is our future. In a recent essay, two well-known ocean scientists, Jane Lubchenco and Steve Gaines, wrote, "The ocean sustains and feeds us. It connects us. It is our past and our future. The ocean is not too big to fail, nor is it too big to fix, but it's too big to ignore." Next slide. And with that, I'll turn it back over to James to answer some of your questions.
Chris, thank you very much. And to everyone with us, we apologize. We did have some technical difficulties. Chris, I think attendees were unable to hear the segment of the presentation between the introduction of the video with Kurt Martin and the beginning of your discussion, your mention of offshore wind. Could you revisit that?
I'm sorry, James, could you do one more time?
Yeah, Chris, could you revisit the part of the discussion from the introduction of the video with Cape fisherman Kurt Martin and then the discussion about alternative energy?
Sure, that sounds good. And are you going to try and share the video again or no?
I think maybe we will not, just because we would not want to invite additional technical challenges.
Great. Okay. Yeah. So
video in the chat so people can watch it afterwards.
Okay, that sounds great.
Great.
So what I was saying in the lead up is that for decades, the biggest impact on our oceans has been unsustainable fishing. But as fisheries management improves that, the impact is being reduced, which is really great. Unfortunately, at the same time, the impacts of climate change are becoming more acute, and especially right here in New England, where our oceans are warming faster than 99% of the world's ocean. So fishermen out in the water, they see these impacts every day. When you have a chance to look at the video, which is on our website and in the link that we'll share, you can see one of our partners, Kurt Martin, who fishes out on the Outer Cape, talk about his experience with climate change, and which is really all about adapting. That's what fishermen can do. They are really good at trying to adapt to changing conditions. It's our role to think about how we can actually change the future by reducing greenhouse gas emissions and combating climate change. So here in Massachusetts, offshore wind's a really big part of that. And we support the governor's commitment to make the Commonwealth net zero by 2050. And offshore wind is part of that process.
Thank you, Chris. I believe that recapped the segment that for which the audio disappeared. And to everyone, we will send a follow-up thank you a couple of days after the webinar, and we'll be sure to also include the link to the video there. It is in the chat box right now as well. So thanks for your patience.
And you could also check it out at nature.org/massfisheries, all one word. That's actually on the thank you slide.
Great, great. Yeah, thank you, Chris. So we have, we're starting to get a number of questions, and thanks everyone for asking those questions, and please continue to do so. So hold on just a second. Chris, one attendee is interested to hear your thoughts on recent developments in offshore marine aquaculture in the US, recent executive order and then the draft AQUAA bill in Congress?
Sure. Yeah. Um, in the U.S., offshore aquaculture, so we're talking outside of bays and harbors, doesn't really exist yet. One of the reasons is it's extremely challenging to permit, and there's been a lot of public disinterest in having offshore aquaculture. The president's new executive order does a few things, but one of them that's important is that it designates the National Marine Fisheries and NOAA Fisheries as the lead federal agency on permitting offshore aquaculture. There are other agencies involved, including the Army Corps of Engineers, but now the National Marine Fisheries Service is the lead agency. The hope is, I think, that they're the people who understand fish, and they'll be best able to do sensible permitting for offshore aquaculture. The Aqua Act also is a bill that was proposed in Congress, which hasn't passed yet, I don't believe, which again is working to try and make it easier to permit aquaculture. Globally, it's pretty amazing. Globally, fisheries catch has plateaued for about the last decade at about 80 million metric tons, which is an astonishing number. But in the last year, the amount of aquaculture has actually surpassed that. So now global aquaculture makes up more than the entire global wild catch of fisheries. And as we think about 10 or whatever billion people on the planet, harvesting more seafood from our oceans is going to be a really important part of that. So the Nature Conservancy is working with aquaculture farmers here in Massachusetts and elsewhere to better understand the positive and negative impacts of that gear and help think about how to make aquaculture a bigger part of our seafood future.
Thank you, Chris. Another question, is it realistic to expect sustainable cod fishing for the next 20 or 30 years?
It's really hard to know. One of the things that's happened in a lot of places in the world is that we see these incredible recoveries of fish stocks when there are modest changes to management. We've certainly seen a huge reduction in the fishing effort and the catch of cod, both in the US and Canada in the last few years. And there are some early signs that those changes are beginning to show some positive signs. One thing that's pretty interesting, I mentioned that we're doing some research down in Rhode Island. Rhode Island is really the southernmost extent of the cod stock here in the United States. 2 years ago, there were an unbelievable number of cod being caught by recreational fishermen in Rhode Island. In other fisheries in Rhode Island, like in the lobster fishery, the temperatures have driven lobsters away from southern New England quite a bit, but suddenly it seems like the cod are coming back. So I don't know, it's hard to say, but that's something that we're working on, is to try and see how we can give them the best chance of success.
Chris, segueing from that, could you provide a little bit more detail on the cod closure? Did it happen around mating time? How compliant are fishermen? How long has it been in place? The prospects for it?
Yeah, so the way fisheries management is very complicated, and there are a lot of closures. Some of them are year-round closures where fishermen can't fish in there any time of the year. Those are mostly in areas that are really important for habitat, where fishing gear might damage habitat and they're trying to protect that. In the case of the cod closure, it's a seasonal spawning closure that's in effect in November, December, and January. There are also spring seasonal cod spawning closures in other areas. And there are other spawning closures for different fish species, both in state and federal waters. Fishermen are really highly regulated. Every commercial fishing vessel is required to have this satellite monitoring tool called a vessel monitoring system, so that the government knows where the fishing boats are all the time. And so there is really no fishermen don't go in closed areas because it's immediately obvious. So I think the compliance is very high because we have really good tools for monitoring that. And we're working to try and get some research done in the coming years to see whether or not that spawning aggregation that we documented is still thriving at the way it once was.
With regard to electronic monitoring, Chris, why are we only documenting discard, and what does that data provide you?
Yeah, so good question. When we talk about fisheries, we call everything that comes on board the boat, we call catch. And catch is then broken up into landings, the things that fishermen bring ashore and get paid for, and discards, things that fishermen are required to discard. And it's important to say that the way the regulations are set up, fishermen are required to discard mostly small fish. And the idea is that those small fish aren't big enough to reproduce yet. And so we don't want the fishery targeting those fish before they have a chance to reproduce. When fishermen catch and then discard those small fish, it takes away from the total number of fish that they can catch over the course of a year. So that creates an economic incentive for them to not catch them and adjust their gear to do that. And so most of the fisheries are pretty clean. You might see like 5 or 10% of the catch in discards. And so we have pretty good records of what comes to the dock. That's where the money changes hands, and it's all sort of in the light of day. We don't have great information about what happens at sea. And so what we really want to know is what's the total catch? And if we can add the information we don't have about at-sea discards, and then add that to the information we do have about landings, we can create a really full picture.
Chris, how do we address the conflict of interest where fleets of vessels owned by large corporations are able to successfully lobby state and federal government for laws favorable to them, but that are unfavorable to the fishery long term?
That there's certainly been, that has certainly happened in the past. It's interesting to think about it in the New England context, where the fishery that I've been talking about is the groundfish fishery, which is fishermen fishing for cod and haddock and flounders and those kind of things. There are about 200 and a little over 200 active boats in that fishery, which is down from maybe 800 a decade ago. Of those boats, about 80% of them are small boats. And so when we think about the voices that are influencing management, it's the big boats have a say, but there are a lot of small boat operators. And we work with both because it's really important to be able to work across the entire scale of the fishery. Small boat operators typically fish a little closer to shore. Big boat operators typically fish a little farther from shore, and so we're working with both boats, and I think that the influence of big vessel operators in New England on regulations is certainly a lot less than it once was. And the way the council process works, which is an incredibly democratic process in all of the good and bad ways of democracy, it's this really open public process. There's not a lot of opportunity for big boats to have more say than others, I think. Maybe that's a somewhat naive response, but that's my impression as we look at what's happened, at least in the decade I've been working in this fishery.
Chris, going back to electronic monitoring, question about the discarded fish. Aren't the discarded fish already dead?
It really depends. We're working with fishermen using different gear types. So we work with trawlers, we work with gill net fishermen, we work with longline fishermen and jig fishermen. So depending on how fishermen handle the fish makes a big difference on how many of the fish that are discarded don't survive. We call that discard mortality. So one of the main reasons why, for instance, the longline and hook fishermen want to use electronic monitoring is because they barely have to handle the fish at all. The fish comes off the line, they set it on a measuring strip right next to them, and they drop it back in the water. That's why those guys use that gear type is because they want those young fish to survive, and they think that's a really important part of the sustainability of that fishery. There's also other things that people can do. It depends on how long vessels tow their nets for. It depends on the weather. If you take fish from the dark, cold water and you dump them on a 90-degree deck on a hot summer day, they don't do that well. You take them and you land them on a nice cold deck. A lot of fishermen actually land them directly in a flooded deck. You can see a lot more survival. So yes, certainly there's discard mortality, and fishermen who are interested in reducing that have a lot of ways. One of the best ways is just to not catch them at all. And so a lot of the fishermen we've worked with have tried to change their gear type to, or modify their gear in order to catch fewer small fish, which is really great.
So, Chris, do fishermen receive training to help with quality assurance and control of data collected through the video capture?
Through our program, yes, they do. Yeah. So we contract with a service provider who installs the technology on board the vessels and does the technical support. The fishermen have a training session with the service provider, and they have written documents and quick study guides and that kind of thing. But for the most part, what we find is that when a fisherman first joins the program, there's a little bit of getting used to it, and then very soon it just becomes how they handle the fish. It's just their new normal. It becomes part of their routine, and they're highly efficient at it, and they're able to process the catch really quickly. We find on average, when we ask fishermen, they say it takes them maybe like 15 minutes per tow. So like a small dragger might do like 4 tows in a day. So it takes them about 15 extra minutes to process the catch for the video, which really isn't that much time, and they're willing to do it. Because again, these guys are all volunteering to get this technology to work.
I think, Chris, we're talking in this case about commercial fisheries. What about recreational fisheries? How much of the total mortality comes from recreational fisheries, and is there accountability for that catch?
Yeah, great question. So it really depends on the species. You could imagine sort of the closer a species lives to shore, the easier access there is for recreational fisheries. Now, recreational fisheries, we divide them into 2 groups. The charter boats. So if I wanted to go down to the dock and go out on a charter boat, that's actually considered a recreational fishing boat. In New England, there's actually 900 charter for hire boats, which is quite a lot. And last year, I actually ran the first in the nation, maybe first in the world, electronic monitoring pilot on 2 different charter boats to see how we could use the technology on those boats. And it was pretty successful. It's actually really easy because they don't catch that many fish compared to a commercial boat. And generally the fish are all kind of coming aboard in 1 or 2 places. So that technology actually works really well. It's early days before we might see anything roll out there. But then the other part is, you and me, the private anglers. And for some species, like striped bass is a great example of a species where most of the catch is recreational. And most of the mortality is actually discards. So there are, the limit for the size, the minimum size of a fish for striped bass, I think maybe it's 28 inches this year. But there's a lot of fish that are smaller than that. And, when fishermen catch those, there's a lot of trainings out there and trying to teach people how to safely unhook and put the fish back in the water so they survive, but some of those die as well. There are a lot of people thinking about how we could use smartphone apps to help collect better data about recreational fisheries. Whether it's like encouraging people to enter what they catch. There are a lot of interesting ideas about there, but that's really the next frontier on data quality. As commercial fishery data is improving all across the country, more and more people are starting to improve the for hire data. It's turning our attention to private anglers and how to best characterize the catch, because again, in some species, it's really big. And in other areas, like in other parts of the US, in the Southeast US, there's very little commercial fishing activity, and almost all the catch is by private anglers. So New England still has a lot of commercial harvests, just like Alaska and California, maybe.
You mentioned size limits. One question is, I've read about a paradoxical approach to limits, prohibit landing large fish rather than small, since the largest can be super prolific breeders. What are your thoughts about that?
Yeah, there's an interesting management. I think I'm going to show my ignorance a little bit here, but there's a management idea called slot fishing, which is basically doing both of those. And so instead of having, so you have a minimum size and a maximum size. And there are some states that are exploring a slot fishing limit for striped bass for exactly that reason. So maybe you catch and can keep fish from 28 inches to 35 inches or something like that. And therefore the largest fish, which are the most prolific spawners, we call them the big old fat females, the BOFs, in fisheries management, but those fish then are let go. In commercial fisheries, it's a little harder to do that, again, because of the gear type. When you're talking about an offshore trawler, a lot of those fish, again, don't survive, and so it's much harder to get value out of a slot limit. But there really are. It's a really good idea, and there are more people talking about it. And I think we're going to see more movement towards that.
Thank you, Chris. And going back to your presentation, a specific question. On the map of the cod spawning areas near Stellwagen Bank, there were many gray lines, mostly going east-west. Are those the tracks of tagged cod? If not, what are they?
No, good question. I don't know, well, it's not worth putting the figure back up, but what you would see in that figure is those little gray lines were actually the track that the glider took. So we had, over the different fishing years, we had 1 or 2 gliders zigzagging back and forth across the entire area. And what we did was we had an area where we had 50 of the toll booths, the receivers, in the water, listening for the tagged fish. And then we had the glider look at a larger area than that. So we went past the boundary of where the fixed stations were, so we could know whether or not we were capturing the edge. And over the course of our project, we had the receivers in the water for 3 years. We actually used the glider data to help us shift our fixed array to be in the most ideal location. So the glider was really great at spanning a larger area, and that's what those gray track lines are. There's a great website that you could check out from our collaborator at Woods Hole Oceanographic. If you Google robots and then the number 4 whales, robots for whales, you would find his website, and he does a lot of glider work with not only with fish, but also with marine mammals. So there's a lot of cool stuff on that website.
Thank you for that, Chris. We'll be sure to include that in the follow-up after the webinar as well. Can you address the role of sanitary sewer overflow systems in large coastal cities like Boston? Is the Nature Conservancy involved at all in perhaps working with EPA to modify that system which allows for raw sewage to flow directly into the bay or ocean?
Well, we're not really working on that. I don't know that much about it, although interestingly, a few of the fishermen that we collaborate with have been working with the MWRA, or whatever the name of the group is, that manages the sewer overflow, and they have done fishing surveys over the years before the real big pipe went out into the deep water from the Boston sewage treatment plants. And they've done before and after comparisons to try and really understand what those impacts are. My understanding is that they work really hard to make sure that the water that's coming out of the big pipe is as clean as possible. The facility there on Deer Island is state of the art and has taken Boston from, being the theme song of like, love that dirty water, right to being we go out in Boston Harbor all the time, and there's people fishing, there's schools of menhaden, there are whales, there's dolphins. I mean, it's incredible the changes just in my lifetime as a result of that cleanup. So I'm not working on that in particular, but I do know that there is research and monitoring that's been going on for decades to look at those impacts. And my understanding is that there haven't been a lot of problems there.
Great, thank you. A couple of climate-related questions. A couple of people have asked, why is the ocean here 99% warmer than elsewhere?
Yeah, good question. I'm not an oceanographer, but I'll tell you the high-level version as I understand it. But one of the biggest reasons has to do with ocean circulation and the way the water circulates, particularly around the Gulf of Maine and southern New England. For a long time, our waters, if any of you have been swimming off the coast of Maine in the summer, you will know that it is freezing up there. And that's largely due to a big ocean current called the Labrador Current, which comes down the coast of Canada and comes into the Gulf of Maine, which has a sort of counterclockwise circulation. The Labrador Current has been slowing down for a variety of reasons related to climate change. And because of that, we have less of that really cold water coming in, and that has allowed the Gulf of Maine and even the water in southern New England to start warming up really rapidly. There's a lot more to that story, but it's basically an ocean circulation story. And I mentioned that the ocean really drives our weather. That's why the climate in Ireland seems sort of similar to the climate in Massachusetts, even though they're 600 miles further north than we are. The ocean moves a huge amount of heat, and in this case, it's moving less of the cold into our waters than it used to. So that creates a relatively rapid change.
We have several questions related to climate impacts on fisheries in the ocean. Maybe quickly, with regard to what you just said, do we anticipate that the cod breeding area will change with water chimps and direction of currents?
Yeah, so one thing that many studies around our waters and in other places have seen is that species are beginning to shift where they live to colder and deeper waters. And we saw that in our project looking at codfish in Massachusetts Bay. The area where the fishermen we were working with thought that we would find spawning fish was a little bit shallower than where we found them to be congregating. There might be other reasons, but there's probably a temperature reason behind that. That same thing has been found in a lot of other places. I mean, the good thing, if there could be
I think Chris we've lost the connection with Chris. Let's see if we can get that back, folks. Apologies for the technical difficulties.
Can you hear me now?
Try it again, Chris.
Can you hear me now?
Yes.
I'll just turn my video off just for
okay.
now to make sure we have good audio.
Yep.
So I guess I was saying that we've seen in many places, both in Gulf of Maine and in other places, fish swim to deeper and colder waters for spawning and for other things. Saw that in our study in the Gulf of Maine. We saw that the fish were in deeper water spawning than where fishermen traditionally had found them. And that's been shown for other species as well. One sort of good side of this is that fish can move really easily. They got tails, as the fishermen would like to say, as opposed to trees, which have a harder time responding to climate change. So assuming that there is habitat that's suitable for those fish, they can move into where the warm, where the appropriate thermal habitat is for them pretty easily. So I think that enables fish to move, and we've seen there have been tons of studies that have shown fish moving in relationship to changing water all over the world, and especially here in New England.
Continuing on the climate theme, there seems to be resistance among commercial fishermen to development of wind farms. Do you see a path to a time when fishermen can support them?
Okay, I'm going to risk turning my video back on here. We'll see how it goes. Like everyone else, my house is full of people also using the internet in this crazy time that we live in. So do I see a time when fishermen will support offshore wind? I think the biggest challenge, well, I'll say, I think what fishermen have told me is one of the biggest fears is a loss of access. So, you know, what happens now, and the ocean is a really busy place now. There are fishermen and shipping and pipelines, and there's all sorts of stuff happening in the ocean, but most of those things can coexist because they are temporal, like they move in time. So a fisherman can fish in the same place that a tanker went by an hour before, and as long as they don't run into each other, everything's good. What you see with development of offshore energy is areas of the ocean that fishermen just won't be able to go, you know, the exact place where the turbine is. I think it remains a little unclear how much access fishermen will have to areas where wind farms are. We have seen a lot of negotiation between the wind farm operators and fishermen in order to space the turbines out and create room for fisheries to be prosecuted inside where the wind farms are. Some fisheries probably won't, but certainly some fisheries will. And probably the biggest thing is the unknown. You know, there's a lot of fear factor, and it's hard to tell people that their fears aren't valid because they are. So I'm hopeful that as we see the first of these large offshore wind projects that might have, you know, 700 turbines, or, you know, we might see 600-700 turbines over the course of the next 5 or 6 years, 80 or 100 at a time in some of these big projects, that we may see that coexistence becomes a little bit more clear and the fear factor will go down a little bit. I think there's still always going to be a little bit of friction because of the space issues. But one of the things that the process has done is try to site wind farms in places where there's the least fishing activity and also where there's the least habitat impact. I think in the areas around Massachusetts, there is a lot of fishing that happens in those places, but there was a long process to try and find areas that had as little impact as there could be. In other places, like closer to New York, where everything is just more dense, there are fewer spots where there's less fishing. So it's going to be harder to site those, the turbines in some areas, and in other areas, there's plenty of space. So is it going to be kumbaya? Not for a while, but I'm hopeful that as we start to see the first projects come out, that some of the fears will be displaced.
So Chris, we have just a few minutes left. I'm going to try to wrench in 2 questions, and I apologize. We apologize to everyone whose questions we don't get to today. It's incredible to have so much engagement, and we really appreciate it. Chris, we'll go to something iconic to the region. Lobster catch, can it be sustained for the next 10 to 20 years, and will the catch grounds switch further north?
Well, I think, will the grounds switch further north? We already know the answer to that, and it's yes. There are some great plots that scientists have done showing the sort of center of lobster fishing effort. And what we've seen is that lobster fishing south of the Cape has really diminished. It's almost not commercially viable in a lot of places, and it's still booming in Maine. But that is moving up the Maine coast, and there are a lot of people working in the lobster fishery who are projecting, that slow change. I don't know the exact timing. It's not, I think 10 years, there'll still be plenty of lobsters around here. 50, harder to say. But yeah, lobster are really clear species that's being impacted by changing water temperature, and we're definitely seeing them move up the coast.
So we have I think a great question to end on, Chris. One that I think you think about a lot, which is, what may we do on the land to help fish in the sea?
Well, I mean, there's probably a lot of things that we can do. Some things, on the fish and seafood side, trying to create more consumer demand for sustainably managed seafood is really important. Fishermen are really attuned to price, and a lot of the time, the price of fish is pretty low, and there's not much incentive to bring in a better quality product, one that was maybe caught with better techniques, because they aren't getting paid for it. In other areas of the world, like in Europe, for example, consumer demand has shifted to really drive sustainability, and we've seen large seafood buyers begin to demand higher standards and pay for it. So I think, as a consumer, trying to find out where your fish comes from, and I think as somebody who works in fisheries, I sort of hate going out for dinner with people because they spend the whole time asking me what I should eat and what I can't eat. My easy answer is almost anything that is caught in the US is managed under the tightest management, some of the tightest management in the world. The overwhelming majority of the seafood we consume comes from outside of the US, and it's a lot harder to say. But if you can look for US caught seafood, I think that you're going to find, generally speaking, really well managed fish. And then there's other little things like, plastic pollution in the ocean is a really big problem. The way we solve that is to not put it in the ocean. So pick up, try and use less plastic, pick stuff up off the beach, be a change agent on the small things in life. But seafood demand is a really big one.
Thank you, Chris. I imagine that people going out to dinner with you do have those questions.
And I'm hopeful these days that anybody is going to go out to dinner with anybody anytime soon. So
right.
Seems like a small problem right now.
No, but thank you so much for the always thought-provoking conversation, the presentation today. Chris, is there anything you would like to add before we sign off?
No, I just say, thanks so much to everyone who joined, and for folks who support the Nature Conservancy and other groups doing important work in this space. This is, the UN has declared the 2020s the decade of the oceans. And I think you're going to hear more and more about how important working in the oceans is to, our collective survival as we begin to manage the impacts of climate change and food security. So stay tuned and keep thinking about the ocean.
Thank you.
It loves you too.
Yeah, thank you. And yes, as Chris was saying, please do stay tuned. We're so grateful to everyone who joins these Nature Connects webinars, and we're grateful for the questions that we receive. We receive a lot of really, really excellent questions. So thank you. We are going to continue the series. You can find out more about upcoming webinars. You can also find recordings of eventually, a few days, we'll have this one up, and previous webinars at nature.org/MA webinars. We'll include that, and as well as some of the other items that were discussed today, links in the follow-up email that we send. And so again, thank you, Chris. Thanks to everyone who joined us today. Wish you the best, and until next time.